In this video, I'm going to show you how to compute numbers raised to negative exponents. Now, we already know how to raise numbers to zero and positive exponents. Let's just take a recap of that for 3. 3 to the third power is just 3 times 3 times 3, which is 27. 3 squared is just 3 times 3, which is 9. 3 to the first is just 3, and then 3 to the 0th power is just 1. But now, how do we compute something like 3 to the exponent of negative 1, or negative 2, or negative 3? Well, why don't we just follow the pattern that reveals itself as we decrease the exponent here? So going from 27 to 9 to 3 to 1 to the next number here, what is the pattern that is happening here? Well, we're just dividing by 3 every time. 27 divided by 3 is 9, and then 9 divided by 3 is 3. Then 3 divided by 3 is 1, so that's telling us that we should just keep on dividing by 3. Let's do that. Let's keep on dividing by 3, and let's see what we get. So 1 divided by 3, well, that's just 1/3. That's interesting. 1/3. That's the reciprocal of 3. So 3 to the power of negative 1 is just the reciprocal of 3. And now the pattern becomes very clear. Each time we decrease the exponent, we're dividing by 3, but really we're just multiplying by 1/3. 27 times a third is just 9, and times a third is 3, times a third is 1. So let's write this down. This is dividing by 3 or times a third. It's two different ways to think about the same thing. So times 1/3, or times 1/3, or times 1/3. Now when we keep on dividing by 3, it's going to be a lot easier to think about this as just multiplying by 1/3 again. So 1/3 times 1/3, how do we compute that? Well, we just have to multiply the numerators. 1 times 1 is 1, and then over the denominators multiplied, 3 times 3 is 9. So 3 to the power of negative 2 is just 1/9. And then again we divide by 3, or you can think about multiplying by 1/3. That's a lot easier to think about it that way, because again we just multiply the numerators. 1 times 1 is 1, and then denominators, 9 times 3 is 27. 1 over 27. Now let's look closer at these negative exponents. We have that 3 to the negative 1 is 1/3. And we also have that 3 to the negative 2 is 1/9. Why don't we write that as 1/3 times 1/3 though, just to make the pattern clear. And then 3 to the negative 3, 3 to negative 3 is just 1 over 27, which is just 1/3 times 1/3 times 1/3. Oh, okay, here we go. So 3 to the negative 1, that is just 1/3 to the first power. 3 to the negative 2, that is just 1/3 to the second power. 3 to the negative 3, that is just 1/3 to the third power. And this leads us to a nice little rule that we have for computing negative exponents. That rule is that, in general, if you take a number a and raise it to the power of negative n, this negative exponent, the way you can compute that is you can just take the reciprocal of a, take 1 over a, and raise that to the nth power. So there we go. That is our major rule that we're going to be referring back to as we compute negative exponents. The main idea is that you can take a negative off of the exponent, provided that you take the reciprocal of the base. So let's apply this in some problems. Alright, so here's a problem. We want to compute 5 to the exponent of negative 2. And how do we do that? Well, remember our rule is that if we have 5 to the power of negative 2, if we have a base raised to a negative exponent, we can just compute that by taking the negative off the exponent and changing the base to its reciprocal. So the base becomes 1/5 now, the reciprocal of 5, 1/5, and then the exponent is now positive 2. 1/5 to the positive 2. And that's a lot easier to compute. We know how to do this. This is just 1/5 times 1/5. Just multiply it by itself. And then 1/5 times 1/5, well, 1 times 1 is just 1 over 5 times 5 is just 25. So there we go, that's our result, 1 over 25. Now how about 2 to the power of negative 4? Well, it's the same idea. So 2 to the power of negative 4, that's just equal to, we take the negative off of the exponent and we change the base to its reciprocal. So 1 half, 1 over 2, is the reciprocal of 2, and then take the negative off, so it's to the power of positive 4. A half to the fourth, well, that's just a half multiplied 4 times, so a half times a half times a half times a half, 1, 2, 3, 4, and then we've just got to multiply this. So let's take the first two halves, a half times a half, well, 1 times 1 is just 1, over 2 times 2 is 4, and then we've still got our times a half times a half. So let's go through another round of multiplication. A fourth times a half, 1 times 1 in the numerator, that's just 1, over 4 times 2 in the denominator, that's just 8, and then that times a half, and the result of that, 1/8 times a half, 1 times 1 in the numerator, over 8 times 2 in the denominator, 16. So there's our result, 1/16. Alright, here are some final examples. First of all, we want to compute 2/3 to the power of negative 3. And we're going to use the same idea that we've been using this whole time. 2/3 to the power of negative 3 is just equal to the reciprocal raised to the power of positive 3. So what's this reciprocal of 2/3? Well, to find the reciprocal of a fraction, you just flip the fraction. So instead of 2/3, we have 3 halves, and then raised to the power of positive 3. There we go, 3 halves raised to the power of positive 3. Let's compute that. That's just 3 halves times 3 halves times 3 halves, 1, 2, 3, and then multiply this out. So 3 halves times 3 halves, well, numerators, 3 times 3 is 9, over denominator, 2 times 2 is 4, and then that times 3 halves, what is that? Well, 9 times 3 is 27, over 4 times 2 is 8. So 27 over 8 is our final result. Okay, next problem. We want to compute the decimal of 0.8 raised to the power of negative 2. Okay, so the way that we've been doing this is just taking the reciprocal of the base here and then raising it to the positive of the exponent. What is the reciprocal of 0.8 though? That's a little bit trickier to figure out. So here's an idea. It's a lot easier to take the reciprocal of a fraction. You just flip the fraction. So why don't we turn 0.8 into a fraction before we start with this whole reciprocal thing? Let's do that. So 0.8, to start out with, 0.8, what fraction is that? Well, 0.8 is just 8/10. It's got an 8 in a tenths place over here. So that's just 8/10, and then we can reduce that fraction a little bit. Both numbers 8 and 10 are even, so we can just divide by 2 on top and bottom, reduce that fraction down to 4/5. Okay, so 0.8 to the power of negative 2 is the same as 4/5 to the power of negative 2. So 4/5 to the power of negative 2, and the way we compute that is we just take the reciprocal, so flip that fraction, instead of 4/5, make it 5/4, and then raise it to the power of positive 2, not negative 2 anymore, positive 2. 5/4 to the power of positive 2. And now we just need to compute that, so 5/4 to the power of positive 2 is just 5/4 times 5/4, and that becomes just the numerators. 5 times 5 is 25, over, in the denominator, 4 times 4 is 16. So 25 over 16. And there we go. There's our result. Great, so now we know how to compute numbers raised to negative exponents. And in the future, we'll continue to become even more comfortable working with negative exponents in more complicated expressions.